Hi Pirates! We're still using our applications of derivatives. Today is a big day, huge. We're going to talk about how f, f prime, and f double prime all connect. We already snuck a lot of this in when we did derivatives and graphing. I know you loved it then. You're going to love it even more now. So the first thing I want you to do is just recall what we already know. We know that if f is increasing, the slope is positive, which means the first derivative is positive. If f is decreasing, this is the original. You don't know say who it is, remember that. My derivative is negative. But now maybe new to you, maybe you've been online researching, are the ideas of concavity. A function is concave up like a cup when the second derivative is positive. Now let's just think, if the second derivative is positive, what would my first derivative have been doing? That would have been increasing. So there's a lot of different puzzle pieces we can talk about here. My function is concave down like a frown, CCD, that's an approved TLA. You can use that on the AP exam. When my second derivative is negative, which also means my first derivative would have been decreasing. A point of inflection, not a point of interest, a point of inflection, a POI, is when my second derivative changes signs. It can change from concave down to concave up, as in a good old John Travolta, or if I have a reverse John Travolta, I might change from concave up to concave down. Those are both considered points of inflection. So what we really need to understand is what's expected to justify. We've hinted at this with our sign charts. We're going to look today at how do I justify given a formula. Given a formula, what kinds of things do I need to do and what do I need to look at? So the first thing, well, when all else fails, I should probably take a derivative. Make sure you are labeling your derivatives. I've seen your work. Some of you are pretty scattered, so make sure as you go through here, you're labeling your derivative. Where do critical values happen? They happen when the derivative is 0 or does not exist. Now, what's different than the absolute question? Do I see the word absolute? I do not. Do I see endpoints? I do not. So at best, all I know is these are relative mins and maxes. I'm going to set my derivative equal to 0. Do a little GCF, a little factoring. Okay, I come up with two critical values of negative or positive 2. You might recall, after that we can create a sign chart of our first derivative. I'm plugging these into the derivative formula. So if I think about, well, what's my favorite number between negative 2 and 2? 0. If I plug in 0, overall I get a negative derivative value. If I were to plug in negative 3, positive 3, 4, 5, positive. So that's my first derivative sign chart. I'm now going to do the same thing for the second derivative. So after I get my first derivative, hopefully correctly, ideally, because otherwise it's not going to go well, I get 6x. I set that equal to 0. My second derivative has a critical value at 0. I make a second derivative sign chart. It is crucial that these are accurate because you're going to use it to identify everything along the way. If I take negative number and plug it in here, I get a negative. If I take a positive, okay, I get a positive here. Now, I did not ask you about increasing, decreasing, concave up, concave down, but you would make those decisions from these two sign charts based on the facts that we know. All right, so now I want to figure out maxes and mins using my first derivative test. This is AP approved justification. Mr. Barnes approved justification. So I look at my first derivative. Remember this from when we did graphing. I see positive, my function was increasing. I see negative, my function was decreasing. What do we have at negative 2? We have a maximum. So I have a max at x equals negative 2, but your justification are your feelings. Why do you feel that way? We've always got to talk about your feelings. I feel that way because my derivative was equal to 0. My derivative in general was greater than 0 on the interval to the left, and my derivative in general was less than 0 on the interval to the right. This is the first derivative test for maxes and mins. Similarly, at 2, I have a negative derivative, decreasing original, followed by a positive. Well, sounds like that's a minimum. Okay, same idea. I have a minimum at x equals 2. My feelings, I feel that way because my first derivative is 0. My first derivative in general was less than 0 to the left and greater than 0 to the right. This little recipe is AP approved justification. We got to practice. We need to practice accurately. Okay, so this next one is called the second derivative test. Sounds like I should use the second derivative, but that's a lie, friends. This is really the combo test. You are using both the first and second derivative combined together to make a decision. The other thing you need to know about this test, it's the same answers as the first derivative test. It's not a new answer to a new formula. Same answers, different feelings. So what I want you to think about right away, rewrite those answers. I've got a max at x equals negative 2. I have a min at x equals 2. Let's talk about our feelings. If I'm at a maximum, maybe draw a little picture for yourself. I always find that helpful. My first derivative is 0, horizontal tangent. But now my second derivative, well, if I'm at a maximum, I'm actually concave down like a frown. So my second derivative is actually a negative number. You can prove that with the sign chart of your second derivative. It should agree with what you're finding. If I have a minimum at 2, well, let's see what's happening. My first derivative is 0, horizontal tangent. My second derivative, well, if I'm a minimum, I'm actually concave up like a cup, which means my second derivative is positive. Okay, so first derivative test uses the first derivative. Second derivative test uses both. Its name is a lie. Be careful. Last but not least, we want to find a point of inflection. A point of inflection only uses the second derivative sign chart. So I look at my sign chart. It changes on the second derivative from negative to positive at 0. Now please note, as we get fancier, which we always do, if it's not a point on the original, it can't be a point of inflection. Vertical asymptotes never count. I feel this way because my second derivative was 0 at that moment in time. My second derivative in general was negative to the left and positive to the right. Work on practicing accurately with your justifications. Now the whole idea is that we can sketch the original curve, and we're going to have some really great curve sketches coming up in this course. So from all this information, and you've done this before when we did derivatives, we're trying to get a picture of what the original looks like. So first we have a max at negative 2 and a min at 2. I'm not going to worry about where they are, although if I wanted to, points come from the original, I could plug it in. I've got a relative max, okay, and I've got a relative min. Now a point of inflection, possibly new to you, I usually put that on the picture as a little plus sign. At 0 we'd be at negative 5, so we could guesstimate that. Just to remind myself, I need to flip. I started off increasing concave down, then I was decreasing, still concave down, decreasing concave up, we'll just make that bigger, increasing concave up. Again, this is a graph of your original function. This is going to give you a way to graph functions you didn't previously know. Enjoy.